I am SANGCHOUL Yi, Senior Researcher at Korea Maritime Institute. It's my great honor having you at my video presentation. Today I am going to talk about innovation in Korean aquaculture with some cases. Today's talk consists of 3 parts. The first is the current status and challenges of Korean aquaculture industry. The second is a response to sustainability issues in aquaculture. Finally, innovation outcomes. In order to understand the Korean aquaculture industry, it is necessary to analyze the current situation and the environment analysis of this industry. First of all, we can look into the scale of the Korean aquaculture sector. This graph shows the volatility of scale along with the development history of Korean fisheries. The fishery production in Korea has shown a steady pace since 1990. But, if we analyze it closely, the fishery production has been on a decline, making up for it through the increase in aquaculture production. As you see this graph here, the aquaculture production has been growing rapidly since 2001, and superficially, it shows a solid growth trend. But, if you look at this by each category, each growth trend is showing a different pattern. As you can see from this graph, the crustacean category has increased in recent years, but the fish category that is representative of high-value aquaculture species has shown stagnant growth. And the seaweed that is a representative product has been leading the increase in Korean aquaculture production. On the other hand, the production of shellfish such as oysters and abalones is unstable due to high production volatility. Especially, the stagnation of fish farming raises the need to look at its competitiveness, considering the phenomenon of a surge in imports of Atlantic salmon over the same period. Unlike the external growth of the Korean aquaculture industry, this industry internally is facing sustainability issues. To be specific, an existing production method that depends on the natural environment and labor forces threatening the sustainability of the Korean aquaculture industry due to increased damage and the mortality rate caused by natural disasters. To systematically diagnose these sustainability issues, I will show you a SWOT analysis that we conducted. The strengths of the Korean aquaculture include effective management by specialized breed varieties, high awareness of food safety, FDA-designated waters, etc. Easy acquisition of eco-friendly production information, application of ICT technology to aquaculture, etc. On the other hand, the weaknesses include ambiguity of eco-friendly aquaculture and policy, absence of integrated information system on sustainable aquaculture products, high production cost for sustainable aquaculture, unstable sales market for eco-friendly seafood, little price differentiation between conventional aquaculture product and sustainable aquaculture, etc. If we look at the external factors, the weaknesses of the Korean aquaculture include mandatory use of formula feed, extruded pellet, expansion of sustainable consumption linked with large grocery chain, proliferation of fourth industrial revolution technology in the primary industry. And the threats include expansion of new diseases caused by climate change, proliferation of international aquaculture norms, consumer movement expansion, the concept of sustainable aquaculture expansion, environmental pollution issues in aquaculture. This analysis implies that Korea needs to change through innovation rather than maintain its current aquaculture system. We can mobilize various policy measures to overcome the current situation facing Korea, but the most convincing measure of them is securing industrial competitiveness through technology development and enhancing sustainability. This figure is a diagram of the Korean Science and AMP Technology Development Framework. On the top, you can see the national R&D plans, and on the below, the ministry-level plans. We are currently in the process of the second Ocean Korea 21 plan. The plan in the marine and fisheries sector is the R&D mid-long-term plan, and this plan contains plans from 2014 to 2020. More specifically, there is a Fisheries Innovation 2030 plan in the fisheries sector, and this plan includes an innovative technology development plan called Aquafarm 4.0. The Aquafarm 4.0 project is a national innovation project aimed at improving the productivity of domestic fish farming and supporting the managerial improvement of fish farms. The main points are the digital development of seeds through the digitalization of fish breeding information and smart aquaculture and automation using AI technologies. The policy justification for the Aquafarm 4.0 project was confirmed through interest at the national level and demand surveys in the field. The background for this project is not irrelevant to domestic and international research and development tendencies. In Korea, the Fishery Commercialization Technology Development Project has been leading the innovation in the fisheries sector, but now it is a downward project in terms of government policy projects. So this related financial resource will be concentrated on the Aquafarm 4.0 project. To be more specific, the Aquafarm 4.0 project is to secure the original technology of smart aquaculture in the aquaculture sector by investing 605 billion won over the next 7 years. For your information, this new technology developed is being carried out as a private project, but since this technology developed for public purposes, it can be shared through ODA projects for human prosperity. Actually, Korea has been carrying forward the ODA projects in Vietnam and Indonesia to develop and distribute smart aquaculture technology in developing countries in cooperation with FAO. And also, the Aquafarm 4.0 project will be linked with the ongoing Smart Aquaculture Cluster project. The Smart Aquaculture Cluster project is a business that spreads technology development performance through demonstration business rather than technology development. Currently, the Smart Aquaculture Cluster in Korea is being carried out in Jiangsu-gun, Busan, Gosung-gun, Gyeong Province, Sinan-gun, Jeolla Province, and an additional one will be designated by the end of this year. For Busan, the project will cost 30 billion won to create a smart aquaculture test bed, 10 billion to build a hinterland, and it will be carried out a demonstration project to cultivate cold water fish species such as salmon and sabafish. In the hinterland, a private-centered R&D center and startup incubation center will be established together to become an innovative cluster in the aquaculture sector. The project site in Gosung, Gyeongsang Province is located in the southeast of Korea. In Gosung, an eco-friendly aquaculture cluster will be created using waste heat of condenser effluent from the power plant. And also, the demonstration test bed and aquaculture production complex will be built on a 10-hectare piece of land. The project cost is about 40 billion won, which is the same as the Busan project, and the aquaculture production complex is carried out by attracting private investment. As major aquaculture species, the cultivation of Chinese convict groupers and shrimp will proceed. The project site in Sinan is located in the southwest of Korea. This site was recently designated, producing specialized species such as shrimp and sea cucumber. A business structure of these species is designed as one processing-oriented facility by establishing processing and distribution facilities together, which links aquaculture production to processing. The smart aquaculture cluster that I explained earlier is being created in this technology diffusion strategy, as you can see on the screen. For Busan, it is a technology commercialization cluster. For Gosung, it could be a production-oriented or Green New Deal cluster. And for Sinan, a processing and distribution cluster is also being established. The Aquafarm 4.0 technology project is a business that is being promoted to secure the original technology for the current projects. Through the linkage of these two projects, the smart aquaculture technology will spread out and apply to fish farms in Korea. These attempts of Korea are expected to a great experience of promoting innovation in the aquaculture sector along with technologies. Moreover, these experiences are expected to be shared as human heritage through ODA projects. We especially would like to share this with fisheries leading countries such as Peru to promote its spread in many regions. I would like to take some time to answer some questions that I was asked before this presentation. The first question is recommendations about Peru. To be specific, the question is, what would be the recommendations and contributions for the development of innovative and entrepreneurial aquaculture with an ecosystem approach in Peru? The suggestion that I want to give you is integrated agriculture-aquaculture, which is a typical method among ecosystem approaches. Currently, FAO-led researches and distribution projects on this topic are underway. In October of last year, an international conference on the spread of the IAA was held in Shanghai hosted by FAO. As you see on the screen, this illustration is a case of the IAA in Korea, which represents how to cultivate loach and rice at the same time. The IAA can make us produce a mix of different crops and fish species depending on local conditions. The existing method is a method that links intensive pond culture system, livestock, and agriculture, while the method that I want to propose for Peru is to promote the smart IAA by fusion of smart aquaculture technologies. Representatively, applicable technologies are remote environmental monitoring and ecosystem management technologies using ICT. The second question is basic and fundamental at the same time. To be specific, the question is, what would be the preponderant factors for the development of a sustainable and profitable aquaculture? My suggestion for this question is to focus on sustainability first and rethink it. In other words, I want you to focus on the underlying problem. So, sustainability is a concept that exists when economic, environmental, and social sustainability components of sustainability are compatible, not just the environment. For instance, natural destructive aquaculture like shrimp farming in Southeast Asia has suffered massive damage from diseases along with the destruction of mangrove forests. And as you all know, Atlantic salmon farming in Chile has resulted in massive deaths of salmons. Through this event, large-scale job losses have started so that economic, environmental, and social components of sustainability were threatened. In conclusion, we all can see that the balance of sustainability will be the first prerequisite for sustainable and profitable aquaculture. Thank you for your time and attention.